Hi guys, it's Miss Long here. I'm going to go ahead and do the spring scale lab experiment for you because I know that I don't have some of these materials at home. And I know I have them here at school. Okay, so if you don't have these materials at home, go ahead and watch what I do in this video, and then it can help you answer those questions for your task. Okay, so I've got my ramp already set up here, and I've got all of my materials. I want you to take a closer look at what we're using to see how much force is needed to pull up these items. This is called a spring scale, okay? And look very carefully. One side have the gram side, and that looks like whole numbers, right? We've got a 0, 50, 100. And then the other side is newtons, and that is in decimals. So you see how when it says 50, then that is actually 5/10 in newtons. Okay, so I'm actually going to use both sides, but I know on Canvas it says either or is fine. So what it does is when I hook this in my cup, and then I'm going to put those items in, and I'm going to drag it, then this little scale in the middle, I'm going to kind of pull it so you can see, it pulls down, okay? So let's give it a shot. So the first one was the Slinky. And this is not like your normal little Slinky. This is a pretty big Slinky. It's kind of heavy. And actually when I put it in this cup, I kind of have to put my hand on it because it's so heavy that it tips the cup over. So I'm going to try my best here. And here we go. All right, so up this ramp, I'll take the Slinky out. Whoops. I saw that it was, I'm going to show you here, it was about 90 grams. It didn't reach 100 just quite yet. So 90 grams or 9/10 newtons. So that's what I am going to write in my notebook. Okay, so I had Slinky. I'm going to put 90 grams or 9/10 newtons. Okay, like that in my notebook. All right, so next one, I'm going to make sure this is all the way back to 0. My next one is a flashlight. Now, I could only find a little mini flashlight, so we're just going to use that. And it's pretty light. It's little and it's very light. So I'm going to put that in there. And here we go. So now this one looks like it reached 40 grams. It's right above the 50 mark. So 40 or 4/10 newtons. Okay, and our last one we've got here is the battery. Here's the battery. It's a pretty big battery. It's the D battery. Okay, so it's pretty, comparing it with the flashlight, it's pretty about the same weight, so we'll just see what this one comes up with. Yeah, so this one is more of 60 grams. Okay, this one's a little bit more than the 50. And when I felt it in my hand, it did feel a little bit heavier than that mini flashlight. So this is what I found using the spring scale. Found that the Slinky was 90 grams, the mini flashlight was 40 grams, and the battery was 60 grams. So using my data, now we can answer those questions down at the bottom. Which item took the most grams or newtons? And then think, why do you think that item took the most? Okay, so you can copy down this data in your notebook, and then you can answer those questions if you would like. I'll give you a couple more seconds to look at this. Okay, and I want to go over these items again. That first one, this is a slinky, and it's a big slinky, and it actually is pretty heavy because if you stretch it out, it's very long. So it's when it's all packed together, it's kind of heavy. This mini flashlight is like very, very light. Very, very light. And then this battery, I would say, would be right in the middle. It's a little heavier than the mini flashlight, okay? So using my data, if you do not have these materials, go ahead and just use what I found to answer those questions for your